Hello, Science Nines. I wanted to just talk a little bit more. I made a post about some information regarding wet cells. Normally in class, we'd actually make one of these and we'd have some chances to test different metals and whatnot. But in light of the fact that we can't do that, I do want you to understand some additional principles about a wet cell. I did post a video that's really good. It shows, I know it's a bit dated, but it does show how easy it is to create a wet cell, and it emphasizes the importance of the electrolyte. Okay, and again, for a wet cell, the electrolyte is a liquid, just like car batteries or uh, any acid battery uses a liquid electrolyte. So the principles are pretty straightforward, but you need to know that for a wet cell, what you need are two dissimilar metals, is the term that's used. Metals that aren't the same. So in this one, we have, you can see we have a copper cathode over here, and then a zinc anode over here. I'm not really worried that you know which one's the anode and which one's the cathode. For our purposes, you definitely just need to know that they are different metals. So if you put two copper strips into an electrolyte and tried to measure a current or a voltage, nothing would happen because basically each metal wants electrons at a different affinity, it's called, or a different rate. You'll see that in the notes below. So um, you have the two electrodes, which are the metals, and then the electrolyte is the liquid. Okay, so in here, there have to be some form of ions. Ions are just elements or atoms that have either lost or gained electrons, and so we show them as being positive if they've lost electrons, negative if they've gained some. You should be kind of familiar with that because you guys did chemistry already. And as long as the electrolyte has ions in it, then a chemical reaction will happen, and you just need to know that that means that electrons will flow through the electrolyte and through the electrodes. Now, the only way we can really tell if that's even happening is if well, I guess you could put an LED in here like this one shows, which is kind of cool. I know it's a little blurry, but the yellow dots, I believe, are signifying electrons. So the movement of electrons through the, basically through the circuits, really, that we're creating. But they're flowing from the zinc to the copper in the top part and allowing the LED to light up. The only way we can really measure that is if we use a voltmeter. Now this picture, this is an analog voltmeter. It's exactly like the ones you would have used in the lab had we done it. And it's an analog one because it just has a little dial right there. You can see that dial is at 0. If there is a voltage, the dial swings over, and then you can measure the voltage or whatever. And we hook up what are called leads. They're basically alligator clips that actually, I guess we could even back up here if I really wanted to. We could attach a lead right here and run that to one of the terminals, and then attach another lead off of the copper and attach it to that lead right there. That's how these work. It's a pretty easy method. And that way the voltmeter, and you can see the V for voltage, will measure the volts. Okay, so that's the potential difference in energy. Now we could just as easy use an ammeter instead of a voltmeter, but an ammeter would measure amps. And we'll see this pretty quick in our next section, but most of the time you'll see, maybe even if your parents do a little bit of electrical work at home, you might have seen one of these. This is a multimeter. It looks something like this. It has a dial in the center that allows you to change to a number of different settings. Eventually we'll learn that you can use a multimeter to measure the voltage. You could use it to measure the current in amps. And you can also measure a property called resistance, which is measured in ohms. We'll learn about that soon enough, but that's not on this section, but it's coming up. So, but it does require that you have two leads or two probes, I guess, these guys right here that are connected to the multimeter, and they need to touch two parts in a circuit to either measure the resistance over that part or the voltage or the current flow. So let's just go back here. So again, here this little sketch at the bottom shows a voltmeter hooked up to copper. Actually, this is a copper cathode, and looks like the anode also has some copper in it as well. So um, that I don't want, the colors are probably better here. I don't want you to think that you can get a voltage with two copper cathodes, although one is negative and one's positive. So I'm not sure. Anyway, there's some other chemistry going on in this picture. The main thing I wanted you to see, though, is that the voltmeter is connected to the leads, or connected to the electrodes. Okay, so the summary, I put this down here in the notes. You can kind of read it over to, we've already discussed it for the most part. But wet cells actually use a liquid electrolyte. That's the definition. Sorry. And they have a liquid electrolyte is an active chemical solution. If we just turn on the tap water in your home, it will have ions in it. Not a lot, but it's not distilled water. What's coming out of your tap is not pure water. So, we can find ions like calcium is a very common one. We put chlorine in our water. That's chlorine minus, to kill bacteria and keep the water clean. If you live out of town and you have well water, sometimes you can get a little bit of iron in your some iron ions. But most of you have filters probably that takes that out. So, but anyway, there's lots and lots of possible ions. A lot of them are dissolved from minerals that are in the rivers and lakes that the water flows over, and it gets into our water. So that's why we use what are called water softeners sometimes. You guys might be familiar with that. You might even have some in your home. It's just a big tank. It's full of some some salt tablets, and your water supply goes through that, and it actually removes some of the mostly the calcium and some other ions that technically make your water hard. I know it's hard water versus soft water. It's kind of a funny designation. Anyway, you should know that there are liquids that have no ions in them, and they are not useful when making a wet cell. Distilled water is definitely one of those. That's just pure water. So it has no ions in it, and as such will not allow a chemical reaction to happen. Sugar dissolved in water will do the same thing. You might know sugar from your other chemistry, but it has no ions in it either. Okay, so those are kind of two examples of electrolytes that won't work. Essentially, almost anything else will. Definitely acids are a great one. Acids, as you saw in the video, acids and even bases work really well. So the last part here is just a summary again of what we've discussed. Metals need to be dissimilar or just different, okay? The term is affinity. We don't go into that very much in Science 9, but as you take higher levels of chemistry, you'll learn about electronegativity and then the properties of metals and how they want to pick. Some want to pick up electrons more than others. But the main thing is, for a wet cell to work, you need two different metals. And if the names are kind of hidden in that. If you pay attention to different types of batteries, car batteries are sometimes called lead acid batteries, but there's different metals in an acid for that. I was thinking of the nickel cadmium batteries. So that the names just gives it away, because there are two different metals in a nickel cadmium metal often, but other batteries use zinc and manganese and all kinds. There's quite a variety of options, and again, as I mentioned earlier, that technology is getting so much better. The cells and batteries we have now are better and better at producing electricity. So anyway, that's just added. I wanted to make this to add to your knowledge in the other video and the other notes that I've already posted. When we get back after Easter break, I'll maybe let you do a little bit of review on that, and then we'll have a bit of a quiz on all of that vocabulary just to get us started. So anyway, that's it for now.